Alright, today we're going to start our study on ellipses. Basically what an ellipse is what we would call an oval, so you can see the two ovals here. We have two different types of ellipses. We have right here a horizontal ellipse, and we have a vertical ellipse. So let's just kind of look at these equations, just assuming that the center of this ellipse is sitting at 0, 0. You'll notice they're both x squared plus y squared equals 1, x squared plus y squared equals 1. What's switching is the a squared and the b squared and the a squared. And basically all that's going to be is the bigger number will decide if it's horizontal or ellipse. So if the bigger number is what we say is a, is under the x squared, then it's going to be a horizontal ellipse. If the bigger number is under the y, then it's going to be a vertical ellipse. The ellipse have certain features. So it does have a center point right here. We also have vertices. So the main vertices would be on the bigger axis here. And then they have co-vertices running through the center, which would be on the smaller piece here. And they also have two foci sitting inside here, and we find the foci through this formula right here to help us get to where those are. So let's just kind of get started through some examples. I think that'd be the easiest way to do that. So let's take a look. We're looking to graph an ellipse whose equation is x squared plus y squared. And I notice equals 1, I notice the 16's here and the 9's here. Since the bigger number is underneath the x squared, this does mean that we're looking at a horizontal ellipse. So this is going to be the a squared, so I know that a is going to be 4. This is going to be the b squared, so that's going to be 3. I can see there's no minus h minus k happening in here, so my center point is definitely going to be at 0, 0. Because my a is 4, we're going to stretch 4 units. Oh, one more. 1, 2, 3, 4 in each direction here. Since my b is 3, I'm going to stretch 1, 2, 3 up, 1, 2, 3 down. That's going to give us the general shape of an ellipse, or that oval. So I can clearly see the vertices here. You can write them out separate like this. I'm also okay if you write a plus minus 4, 0. That's okay as well. The co-vertices are sitting on the smaller axis running through the center here. So that would be at 0 plus minus 3. When I say major axis or minor axis here, I'm just looking for the length. So this one here is going to have a length of 8. The minor axis is going to have a length of 6. The only thing we're missing from this graph at this point is the foci, and there are 2 of them in an ellipse. There's 1 in a parabola, there's 2 in an ellipse. And again, we find that using the formula a squared minus b squared is equal to c squared, that c distance is going to tell us where that ellipse is. So we're going to have 16 minus 9 is equal to c squared. C squared is equal to 7. So c is equal to plus or minus root 7, not route. I do want exact answers here, so we are going to have to use radicals, simplified radicals, but I need to know where to place this root 7 here. In a calculator, it turns out to be about 2.6, and that's just to help me get about where those foci are sitting in the ellipse. So that's what we need there. Since it's off the horizontal, it's going to be based off whatever the x-coordinate is for the center. Since this one is 0, it's just going to be plus minus root 7, 0 for the foci. Alright, so let's take a look at example 2. Alright, so looking at this ellipse over here, we need to be set equal to 1. So if you see that it's not set equal to 1, the first thing you need to do is divide everything through by 36. What we're going to get over here is x squared over 4 plus y squared over 9 is equal to 1. Now I can see that the bigger number is underneath the y squared. So this means this is going to be a vertical ellipse. So now I know my a value is 3 and my b value is 2. Again, we don't have the minus h minus k, so we are sitting with a center point at 0, 0. Since it is a vertical ellipse, we're going to stretch the major axis up 3, down 3, and then the minor axis will be this way. And we can see that the oval is stretching vertically. So my vertex here is going to be 0 plus minus 3. Our co-vertices are going to be plus minus 2, 0. I can count out the length of the major axis is 6, and the length of the minor axis is 4. The only thing, again, we're missing at this point is the foci on the graph. They will be in this alignment on the major axis here. And again, that's going to be a squared minus b squared is equal to c squared. When we get to hyperbola, this is going to change to a plus. I always remember if the plus is in the equation, then it's the opposite sign when I'm looking for that foci. So it's going to be 9 minus 4 is equal to c squared. C squared is equal to root 5. And again, I need to just kind of get a decimal amount. I need to know where to place that on the graph. That's about 2.2. So it's going to be about here, and here would be the foci. But we're not going to write the decimal version. We want an exact value. Now, since the foci is bouncing off on the, it's going up and down, we're going to add that to the y-coordinate. And again, since it's 0, it's not going to look a little strange. It's going to be plus minus root 5. Alright, so let's flip those papers over. We have example 3 on the back. So again, we're kind of looking here. I want to graph this ellipse. The first thing that I notice is that it's not set equal to 1. So the first thing we're going to do is go ahead and divide everything through by 18. So now I'm going to get x plus 4 squared over 9 plus y plus 2 squared over 2 will equal 1. So you do need to be set equal to 1. I do notice I have a minus h minus k situation happening here. So my center is going to be minus 4 minus 2. So minus 4, 1, 2, 3, 4, minus 2. That is my center point there. I do see that I have an a value of 9. Excuse me, 3 is the root. I have a b value, which would be square root of 2. That is about, again, 1.4. That's just for graphing purposes. So the bigger number is under the x, so this is definitely going to be a horizontal ellipse. I'm going to stretch this out 3 in each direction. 1, 2, 3. 1, 2, 3. So those are my vertices. And this is about 1.4. Again, anytime with fractions, guys, you just got to be in between the right two integers there. The graph's going to look something like this. Alright, so looking to place my vertices, I want to say what they are. I'm going to take the x-coordinate because the vertices are bouncing off the center point. So we're taking the x-coordinate there. I'm going to add and subtract 3 to this both times. So we're going to wind up at negative 1, negative 2, which you can see here. And if I subtracted 3, we'd wind up at negative 7, negative 2. Now we can see these clearly on the graph, but it's not going to be as easy with the co-vertices because of that radical form. Now the co-vertices are bouncing off the y-coordinate of the center point. So we're going to have minus 4, the x-coordinate will stay the same, is going to be minus 2 plus minus root 2. And that's going to get me the exact answer for the co-vertice. The major axis length would be 6. That's pretty easy to count. We have to double root 2 here, so it's going to be 2 root 2. At this point, the only thing that I'm missing is our foci. So again, it's going to be a squared minus b squared is equal to c squared. 9 minus 2 is equal to c squared. 7 is equal to c squared. So the c is square root 7. We said earlier, but that is about 2.6. So 1, 2 is real close to the actual vertices. Again, the foci is bouncing off this x coordinate here. So we're going to have minus 4 plus minus square root 7, and the y coordinate staying the same because these foci did not shift up or down. Okay, let's look at the next guy. Okay, so now we're in a general form. I just need to get this into standard form. We're going to do that by completing the square. So what we're going to do is we're going to gather up the x terms, and there's only the one right here. Then I'm going to gather up the y terms, and I'm going to leave a little bit of space too because I'm going to complete the square. And I'm going to move that minus 9 over to the 9 over to the other side where it becomes a minus. I don't need to do anything with the x squared because we don't have the x term itself. I do want to complete the square here for the y's. Again, I need a 1 lead in front of that x squared. So the first thing I'm going to do is factor out a 3. Okay, still leaving a little space to complete the square. Half of 4 is 2. 2 squared is 4, so I'm going to add 4 over to this side. Now, I'm not just adding 4. This 4 is under control of being multiplied by this 3 here. So when I add to the other side, it's going to be 4 times 3. So I have to add 12 over to the other side. Factoring. And then the last thing I'm going to do, again, we want to be set equal to 1, so we're going to divide everything through by 3. So what I've got is x squared over 3 plus y minus 2 squared, because the 3's will cancel out here, will equal 1. We also need to be able to look at a graph and kind of write the equation of the graph. So the first thing I kind of want to do is get my center point, which would be right here. So the center is going to be the point, what is that? 2, 3, nope, negative 2, 3. So the center is at negative 2, 3. I do see that this is a vertical ellipse, so this is going to be a y squared. So we're always going to be x squared plus y squared is equal to 1. What we need to do is figure out the a's and the b's. The a distance is coming from the center to the main vertex there, which is 3. So that's going to be 9. The a value is coming from the center to the go vertex here, which is 1. And when you squared 1, you just get 1. So this guy also needs the center point put in there. So it's going to be x plus 2 squared. I don't need to put the 1 underneath there. Plus y minus 3 squared over 9 is equal to 1. Looking at this picture here, I do see that I have a horizontal ellipse. So this is going to be, the bigger number will be underneath the x squared. Let's get the center in there to begin with this time. Remember, we're always set equal to 1 here. The main vertex would be here, so that's the main vertex. This would be the co-vertex. This is 3 units away, and remember these numbers are squared here. The bigger number will go under the x because it is horizontal. I'm counting out 2, so this would be over 4, and there's no other work that needs to be done with that. Alright, so let's take a look at these last 2 problems here. Write an equation of an ellipse with a center at 0, 0, a focus at negative 1, 0, and a vertex at 3, 0. You may just kind of want to draw yourself a little picture. So I know I got my vertex at 0, 0. I got a focus over here. So that's my focus at negative 1, 0. And I have a vertex over here at 3, 0. So that's the vertex. So since the center, the foci, and the vertex are all aligned horizontally, I know that I have a horizontal ellipse, and I know that the bigger number will go onto the x squared. I can also see that the center is at 0, 0, so I don't have that minus h minus k thing. So it is going to be x squared plus y squared is equal to 1. I can count out that a value. So from 0, 0 to 3, 0, that would be 3 units. And I square that, that's 9. All right. What I don't know is the b value. I don't know where that covertice is sitting, but I do know a couple of things. I know that my a value is 3. I know that my c value in this case is 1, counting from the vertice to the foci. What I'm looking for is that b value. So we're going to go back to a squared minus b squared is equal to c squared. A is 3, so squared would be 9. I'm looking for b squared, and that's going to equal c squared, which 1 squared is 1, minus b squared would be minus 8, so I know b squared is equal to 8. I don't need the b value. I'm not graphing this thing. I really just need b squared for the formula. So this guy would be over 8, and that would be our equation there. Okay. Last one here. Again, we've got an ellipse with a foci at negative 1, 1. So negative 1, 1. So that would be the foci. And I have another foci, okay, at 3, 1. So 1, 2. So the other foci is at 3, 1. And whose major axis length is 8 units. All right, so the first thing I need to do is find the center. The center will be exactly in the middle of these two foci. So the vertice is going to wind up being, if I add these guys up, negative 1 plus 3 is 2. 2 divided by 2 is 1. So the center point is 1. Adding this other guy up, 1 plus 1 is 2 divided by 2 is 1. So I know I have a center point here. The foci and center, everything is running horizontally, so the bigger number will go under there. So I know it's going to be x minus 1 squared plus y minus 1 squared. We'll always set equal to 1. It tells me that the major axis length is 4 units. So that means the a value would be 4. So that squared would be 16. I don't, again, see that b value. It's not sitting up here. I don't see the covertice. But I do know that there are 2 units in between the center and the foci. So I do know that the c is equal to 2. And again, we're going to go back to that a squared minus b squared. So a squared would be 16 minus b squared is what we're looking for, is equal to c squared, which is 4. Minus b squared would equal negative 12. B squared would equal 12. And again, I don't really need to know what the length of that b is. The square root of 12, I'm not asked to graph this. I'm just asked to write the equation. And that's what we got there. Okay, so that concludes ellipses for today. We'll do part 2 next time.